Okay, and let me just make sure that our YouTube stream is up. Okay, we are up and we are live on YouTube. We currently have 9 viewers on YouTube. You are live.
Okay. Welcome to the Town of East Hampton's panel on all-electric homes. Welcome to those of you in the studio audience and those of you following along online. I'm Biddle Duke, and I'm going to guide the conversation. I want to thank LTV and the Town of East Hampton's Natural Resources Department for organizing the event, particularly Samantha Klein, who's right here, and Lena Tabori, who's next to Samantha. Lena is a member of the town's Energy and Sustainability Committee, and they largely pulled together this event. In addition to Lena, who's going to speak from experience, as she's largely decarbonized her East Hampton home, I want to thank our other panelists. John Barrows, he's a Southampton home builder who specializes in super efficient net zero homes. Jay Best, who's coming to us from Western Long Island, from Green Team Long Island, which is a green energy and heating and cooling efficiency contractor. And you all can correct my bios later when you introduce yourselves, by the way. Brian Stewart, who's coming to us from Portland, Oregon. He started and runs a research and advocacy group called Electrify Now. And Gordian Racky, the executive director of Renewable Energy Long Island, among other things. A quick note about the title of this talk, All Electric. In retrospect, we should have called this Decarbonize Your Life, because that's where we want to go. Burning gas and oil in our homes accounts for more than 16% of America's carbon footprint, which, as you all well know, is heating the planet and dangerously altering life on Earth as we know it. We can change that by decarbonizing. This crew of exceedingly knowledgeable experts in all aspects of decarbonizing can answer why, how, when, and how much it will all cost. We have an hour and a half, and we can learn a lot about the cleanest, safest, healthiest ways to heat and cool our homes, our hot water, our pools, and cook our food. This is an opportunity to have your questions answered. And if you have any questions, please raise your hand, those of you in the studio audience. And if you're online, post your questions in the chat below the screen on YouTube. We're monitoring the chat online, and we're monitoring the audience, obviously, and we'll feed in your questions as they come and as we can. Before I ask each panelist to introduce themselves and offer some remarks, we have a short video which encapsulates much of the ground we want to cover. Should we go?
America is facing a very serious energy problem, and you and I can help solve it.
We've been sold the idea since the 1970s that the solutions to our environmental problems are less. Eating less, driving less, smaller houses, colder houses. That's just not true.
We're just queuing up that video.
We can solve climate change much sooner than we think, and we can do it saving ourselves money.
That opening Decarbonize Your Home video. Thank you.
One moment, please.
America is facing a very
We're having some technical difficulties, it looks like. You guys will let me know if there's going to be a longer delay. We can carry on the conversation without the video for sure. Why don't we begin then? It looks like we have just let me know when you get it queued up, and we'll jump right in. In the meantime, Brian, I thought I'd start with you. I think your story is so interesting and so relevant. Anyway, I thought you'd kick things off with an introduction of your journey and what you're up to and what you hope to accomplish.
Thank you. Thanks, Biddle, and really nice to be here. My background is in design and engineering, and most of my career was at Nike here in Portland. And the latter part of my career, I was vice president of sustainable innovation. So I was focused on how Nike could make shoes and apparel with a lower carbon footprint, less waste, and less water usage. And so I got a good sense of corporate sustainability from that. And when I retired about 4 years ago, I had more time to spend on something I've always been interested in, which is what individuals, people like you and I, can do to help reduce the impacts of climate change or avoid the worst effects that otherwise might happen. And so I had time to dig into this topic, and I felt like I really got a super education on sustainability from a bigger picture once I left Nike. And I realized that energy is at the source of all of these problems, that the ones that we talk about. Energy is the big issue. It's over 70, as much as 80% of the carbon emissions globally are from burning fossil fuels for energy. And I got really excited about all the potential solutions that are available to people like you and I got really excited about how important the choices that people like you and I are in terms of those choices we make about energy in our own lives, and how important those are in terms of helping to accelerate this transformation that's happening with our energy systems away from fossil fuels towards clean energy. And I got even more excited when I started to experiment with some of these solutions myself in our own home here, to see that not only do these things that we're going to talk about today help reduce the impacts of carbon accumulation, but they result in better homes that perform better, they're safer, healthier, etc. So while I was getting excited about this, I was also about this education I was getting, so to speak. I was also getting frustrated that this message wasn't really being well communicated to the public. I mean, at the time, particularly 4 years ago, a lot of you might remember how much the media was talking about plastic straws and things like that, which are, great, important. Waste is an important issue, but it can be a distraction from the real issue at the heart of the problem, which is energy. And so I felt like no one was really talking about these amazing things that we can all do. And since no one else was wanting to do it, my wife and I decided to do it ourselves. And so we started this voluntary organization we call Electrify Now, which is really about trying to help people understand the issue and understand the solutions. And the solutions really come down into 3 buckets, so to speak. Getting clean energy into your homes, all of us can do this. And there's various ways, it's slightly different every place in the country, but you get clean energy, then think about all the things in your home that burn fossil fuels and replace those with electric alternatives. There's an electric alternative that's highly efficient for every one of those things, whether it's a barbecue or a stove or a furnace. And we're going to talk about a lot of those things today. And then our transportation, obviously, moving to EVs is one of the most important ways to help reduce our personal footprints. So, and all these things end up with, you end up, as Saul Griffith was trying to say in the video that didn't work there, is that these are no compromise solutions. These things end up making your life better. So really our job here at Electrify Now is to try to help people understand these things and help people find the resources they need to take action. We've got a lot of people on the panel today who are exactly those type of people who know how to do this. And so I'm excited to be here as part of the conversation.
Can you just tell us a little bit about Electrify Now and where you engage, where the rubber meets the road in terms of, what do you do? What do you accomplish?
Yes, I mean, we are primarily focused on education. So we have our website, which has a lot of information for people about everything from the big picture down to actually how you do these things. How do you install a heat pump water heater, for example, what a heat pump water heater is. And we also do webinars, monthly webinars. We've got one next week on cold climate heat pumps, for example. And we get people from all over the country that tune into our sessions, because we get like next week, for example, we'll have people from Mitsubishi and Daikin talking about the technology, and also people from Efficiency Maine talking about the application of this in a very cold place, these heat pumps, and just to give people confidence that these things really work. So largely what we try to do is provide the information for people to feel confident about taking action and understand how to do it. We do a lot of hand-holding because, and I know Jay will relate to this, people have questions, and a lot of this stuff can feel mysterious and new. So a lot of times what we do is just help people by answering their questions about, how to go about this and what makes sense to do and that sort of thing. So mostly we're education. We get involved in some policy issues here locally to try to make electrification easier and more normal, and less of an exception. But our main focus is education.
Great. Thanks, John. Thanks, Brian. Which is a perfect segue to John, because he's a builder in Southampton who has built super efficient homes that are comfortable and, I think, all electric in some cases, or at least decarbonized fully. And also up north where, among naysayers, people say that it's impossible in places like the Adirondacks and Vermont. And you've built up there as well. So John Barrows.
Do they have the video?
Oh, video. Yes, let's put those photographs up. Can we do that? Oh, the video. Great. Excellent. John, after the video then. Here we have the video. Saul Griffiths.
America is facing a very serious energy problem, and you and I can help solve it.
We've been sold the idea since the 1970s that the solutions to our environmental problems are less. Eating less, driving less, smaller houses, colder houses. That's just not true. We can solve climate change much sooner than we think, and we can do it saving ourselves money. It's the decisions that we make around the kitchen table that affect 40% of the emissions in the country. So a lot of the solutions are right there. We just need to electrify your homes and everything in them. We've got to electrify our furnaces, our hot water heaters, even the way we cook. It means electrifying our cars so they use way less energy, they're quieter, they're cleaner, and they're faster. It means we electrify the heat in our homes so our air quality is better inside. And then the kicker is we just need to supply that with our clean and efficient sources of electricity: wind, solar, renewables. And if we did that, we would eliminate more than half of the energy we think we need, yet our lifestyles wouldn't change at all. If you've ever bought anything on a credit card, you know what it is to get something you want before you can afford it. We now need to do that for the solutions for climate change. We need to provide great financing at the moment you're going to buy a heating solution for your house, at the moment you put solar on your roof, the moment you're out buying a vehicle. What we need is low-cost finance so that we can make the right purchasing decisions every single time. If we get the finance lined up correctly, this is going to be the cheapest solution for every house in America. Think about that for a second. The future can be awesome, and we can save thousands of dollars per year in every household. Our homes can be a vital part of the solution to climate change. We just got to bring them into the future with us. So let's get to work. Let's rewire America.
Pretty persuasive. Part of the conversation a little later will definitely be about clean energy and how to make sure that the power that we're getting out here and across the country is cleaner and cleaner and cleaner. We're going to get to that, Gordy, and that's going to be your task. But first, I want to introduce John Barrows. As I mentioned earlier, he's a builder in Southampton who focuses on net zero clean energy homes, and not only in Southampton, but also in the North Country. John?
Thank you, Biddle. So kind of my history is I was a builder in upstate New York before I moved down here a little over 20 years ago. In the late 80s, I had the opportunity to build a home in the Adirondacks on the point out in the middle of a lake And this gentleman was an inventor. My client was an inventor, and it was my first experience with geothermal heating. And looking back, I didn't know it or recognize it at the time, but that was a totally electric home. And it was not necessarily for environmental concerns, but it was out of necessity, because you could only access this home with a vehicle for maybe like 8 months out of the year, 9 months out of the year, and the rest of the time it was snowbound, so you could only get in by snowcat or Ski-Doo or something like that. So we had a geothermal heat pump. We had induction cooking. There was absolutely no gas or fossil fuel on the site other than the wood pile that was used to kind of create warmth and comfort with a huge thermal mass fireplace that could store the heat and then give off the heat during the evening hours. We'd also had to incorporate a lot of passive solar, south-facing windows overlooking the lake. So we had a lot of natural heating also. So that was my first experience, kind of finding ways to build better and to have the occupants live better, live more comfortably in a healthier environment. And it's kind of been an evolving process over the years. I've noticed that in the last 10 years, the interest has grown. It's gotten to the point where in the last 5 years, we've done pretty much exclusively homes as close to net zero as we could get them. We've done 2 that are totally electric. We've done 2 that are totally electric with the exception of cooking, which I guess we'll talk about later. And we have 1 underway that will be totally electric also. So I'm pretty excited to be part of this panel and discussing ways that we can not only build new, but also take a look at what we can do with the existing homes that we have to make them function better. Because the real key is not only the new homes, but taking what we have that's the stock that we live in now and we've been living in, and how can we make them more carbon neutral also.
Thanks, John. Can we put some of John's? There we go. We have a few photographs of some of his projects here. Tell us a little bit about them.
Okay, this is a totally electric home out here on the East End. It's a rehabilitated barn that has SIP panels, which are structurally insulated panels, as the skin. Has a little bit of rooftop solar, and it's got a heat pump. These are air source heat pumps. I guess we'll talk more about different kinds of heat pumps later. This has an air source heat pump. It has induction cooking, which you kind of see in the background in the kitchen there. And it has a heat pump water heater also. So it's very efficient. Those of you that are familiar with HERS ratings, this has a HERS of -22. So that means we're producing 22% more energy than we're consuming. So if you want to go to the next one. That's a shot. The shot on the left there is the inside of that. They call it the climate barn. The picture on the right, that's the home in the Adirondacks for the client that I had, the inventor. He wanted it to look like an old Adirondack great camp on the outside, but on the inside we had all the bells and whistles that this guy saw in the future. He showed up one weekend in his station wagon from Philadelphia, and he had a roll of 64 pair stranded wire. And he said to us, I want this starting in the basement. I want it run up through all 3 floors, up to the attic even, and back down. No breaks. It's got to be continuous. Because he said, someday I'm going to be able to be in Philadelphia and I'm going to be able to control my heat. Now we do it on the internet, but this was back in 1980. This guy knew that, or was thinking that he could do it. So if you want to advance to the next one. The picture on the left is the interior of that house. We had absolutely no drywall. He wanted no drywall in the place. And then the picture on the right is a home that we've just completed, and that's the piping manifold for a geothermal heat pump. This is where the water comes in from the wells and then it gets distributed to the various air handlers. And then next slide. And this is one that we just completed. This is a totally electric home. with the kitchen in it, and this has a different kind of heat pump water heater, but it is a heat pump water heater. It has air source heat pumps, and it has induction cooking also. So just a couple examples of things that can be done with a clean slate when you're starting from scratch.
Thanks, John. So interestingly enough, a big hurdle for sure is new construction, but existing construction, the housing stock, the building stock is huge, and that remains a massive hurdle for decarbonization, which is a perfect introduction to Jay, whose business is to help us all better insulate, better heat, better cool, better heat our water, more efficiently cook. I'll let you finish that list, Jay, and tell us a little bit about your business and what you're encountering in the marketplace, what you do. Thanks.
Sure. Thank you, everyone, for participating today, and thanks for having me. Just a little bit of background. I, had always been a little bit of an environmentalist. My father was a biology professor, going way back, and so I always had, that I wanted to do something that would, better the world. And I spent some time. I had a degree in environmental chemistry, and at the time, that meant primarily going out to Superfund hazardous waste type sites and taking samples. And I learned that a lot of that was really designed around litigation, and really wasn't too satisfying. It was EPA going after large corporations, and things just moved at a really glacial pace, and wasn't something that I really wanted to keep doing. So I spent a few years going into working in technology, and then as things would have it, ended up unemployed at the start of the Great Recession, and started looking at some different options, and wanted to get back to kind of my roots of doing things environmentally. But I knew I didn't want to do it. I wanted to do something that I felt was going to be closer to home and a little bit more impactful. And I started looking at different opportunities, and came across what is sometimes called building performance. And I started to do energy audits, and really focus. I didn't know a ton about construction, so I didn't want to go build houses like John did, but I had an engineering background, and so I started to learn a lot about homes and doing energy audits. And energy audits were sort of the starting point for me. I started looking at it and making some recommendations to homeowners, and they wanted to. So Jay, this is great. What do we do next? And so within a few months, I found I owned a van and some insulation equipment, and for blowing in cellulose, and started hiring some guys, and started to build a company that ultimately became Green Team. And it's been kind of an interesting evolution where, initially energy efficiency really meant insulation. It meant high efficiency systems for sure, but those were always fossil fuel. And when we wanted to make things better, we switched people from oil to gas, because we felt gas was so much cleaner, without really understanding all of the longer term impacts of gas and fracking and things like that. But the focus was really on making homeowners more comfortable, reducing their bills. And I really love the triple win, which was that I can make your home more comfortable. I can save you money at the same time, and we're doing something that is good for the environment, because as Brian was talking about, and as the video was explaining, that a huge amount of our impact on the world is around this energy use. And there's really no such thing as, unless you have renewables, there's no such thing as clean fossil fuel. It's unfortunate. We've all benefited hugely from it, but even the cleanest forms of it come with all kinds of impacts that we don't always see directly, but they're there. And so in the last few years, we've really gotten into this into electrification, and we've seen a really transformation in the programs that are out there, and they've evolved from being focused on, I mean, they're still focused on insulation, but they've really transformed to have a great emphasis on high efficiency heating and cooling systems, is what we call it. And on Long Island, there's been some bad name applied to the term heat pump over time. So sometimes we wordsmith that a little bit, but they are high efficiency heating systems, and a lot of people really, also enjoy the benefits of that central air conditioning that comes with it. And so that's been a huge end of it. And so, we're fortunate on Long Island, East Hampton being part of that, to have some really great programs. And I'll, get more into that later, that, there's energy audits, and we want to make our homes use less energy for sure. But then the energy that they need, if we can do that with all electric and then make that electric renewable, then we've done all the better.
Thanks, Jay. Lena, I think I'm going to have you go next, actually. Change the order a little bit, because I think you're a perfect segue now, because you actually have done things electric. You've decarbonized to a great extent at your house. You have experience with some of the things that Jay's talking about. So, Lena Tabori, thanks.
You have to talk into the mic.
Of course. I'm Lena Tabori. I've been a publisher all my life, and I co-founded a climate change website in 2017 called climatechangeresources.org, which is a place to go to learn about more or less anything, actually. There's a fabulous, there's a lot there. It's an aggregated website. We basically aggregate to anybody who has something brilliant to say. And that's occupied most of my last 4 years, but then I got to be on the Energy and Sustainability Committee of the town of East Hampton, which recommends to the town board of various things that they feel are critical as we try to reach our goals of 100% clean energy by 2030, which was a goal established already in 2015. East Hampton was one of 2 municipalities to go in that, to take that direction a long time, what seems like an incredibly long time ago. Jay definitely made my home more comfortable, and he also saved me money. And his team was extraordinary. Jay's organization was selected by Energize, which Gordian will talk to later, by the town of East Hampton to help those of us who wanted to transform their homes. I have a 1,400 square foot home that was built in 1920. It's not sited correctly. It certainly wasn't insulated correctly when Jay's team first arrived. And my air conditioning system was failing in the summer of 2020. I was calling my heating and cooling company relentlessly. They were refilling the refrigerant. It was leaking somewhere. No one could figure out where. And it seemed like the perfect moment to do something else. And so I went to Energize. I discovered Jay's organization. They came, they did an energy audit. The first thing they did was to send a crew over to my house to insulate, much better than my house had been insulated, particularly in the attic, which was great. And then they installed air source heat pumps, which took the physical space that my air conditioning units, which had been sitting just outside my living room, there are now 2 beautiful Bosch heat pumps that sit there. And they also exchanged my hot water heater for a 65-gallon Rheem heater. I have to say I've been ridiculously happy with this. My heat is very consistent. I don't have ups and downs. I feel like my humidity in my house is way down, and it's a very comfortable home to live in. I find this piece of technology so curiously counterintuitive. The idea that a piece of technology takes the warm air out of the cold air in the wintertime and puts that into the house so that my house is heated. And in the summertime, it takes the cold air out of the warm air and cools my house. Now that just makes no sense to me at all, but Gordian will explain, I'm sure, how brilliant that is. The other thing that Jay's group did, which I find relentlessly helpful, is to figure out all the rebates and incentives that allowed me to do this most economically. More than $6,000 he managed to find from the state. I don't know where he found it, frankly, but he did. And that left me with about $25,000, which, if I look at my savings, which is now about $2,000 a year, will, I guess pay me back in 12 years. So it's not exactly, a bonanza, but it makes me feel pretty good about myself. I'm a firm believer that if you don't give clean energy somewhere to travel, it can't get to your house. It certainly can't get there through fossil fuels. So electricity is the only way that it's going to get there. And if we now have 40 to 50% of clean energy in our electrical grid, we're aiming towards 70% in the state in 2030, and I suspect we'll make that number.
You're wandering into Gordian's turf now.
Yeah.
He's next.
Of course.
And I'm going to ask him to talk a little bit about that.
I'm putting my machine here down.
Gordian, it's all, electric is wonderful, but and it's considered cleaner energy, and it's qualified because it's not fully clean. I'm prompting your introduction because one of the resistance points around this is people say, well, the electricity that gets delivered out here and everywhere else isn't clean, so we're moving forward and stepping backward all at once. In your introduction, could you talk a little bit about how clean our energy is now and where are we going in the future when it comes to electricity out here?
Sure. So yes, our renewable portion on the electric grid right now is at about 30%, below 30%. So that means about 70-something% comes from dirty fossil fuels and nuclear fuel. Right, so that's the status quo. We've made some progress in recent years, and that has accelerated, but we got to do a whole lot more. Now, I'll talk in a moment about how we're going to do that, but I wanted to first sort of zoom out a little bit here, because we're going to get into a lot of nitty-gritty, because we got a lot of real technical experts here. But you see this water bottle, right? I brought this along to have a sip of water every once in a while, but I also brought it because we can use this as a prop. Scientists have now been able to calculate that we have a remaining amount of greenhouse gases which we can dump into our atmosphere before we reach tipping points, which will mean that we'll see catastrophic and irreversible climate change, and really a catastrophe that will threaten life as we know it. What we have in here in my bottle is the remaining budget. This is what we have left globally. So any BTU of fossil fuel, any gallon of gasoline we're going to burn in our cars, coal in our power plants, natural gas in our power plants, all of that is represented here on a global scale. Now, if you did this with the US remaining carbon budget, this bottle would be empty, because we have contributed the greatest amount of greenhouse gas emissions of any country in the world. So we have nothing really left to spend. If we want to divvy this up based on how much each country in the world has contributed to climate change to date, our tank is empty. So we got to switch to away from fossil fuels and to zero carbon fuels, and that's primarily renewables, right now, today. So with that as a preamble here, Lena already mentioned that we will be at 70% renewable electricity in New York State by the year 2030. That's the law. That's the Climate Leadership and Community Protection Act, which has enshrined that in law. That's just a few years from now, just around the corner. The good news is our state agency that manages that has already procured projects, including projects, offshore wind project like the South Fork Wind Farm and many others that are going to go up, large-scale solar projects and many more. All of those projects to reach that goal are already in the pipeline. So it's happening. We know we're going to get there by, or actually before, 2030. So we'll be 70% renewable electricity. That's not good enough yet because our bottle is empty. So by 2040, we'll have to have reached statewide on our electric grid 100% clean electricity. And we're going to get there, and that's what we have to do. And one important component of that, of course, is that when our boilers, our heating systems reach the end of their useful lifetime, or in some cases before that, that we switch those out for heat pumps. And heat pumps, if they run on electricity, are right now still using fossil fuel because we're using fossil fuel in our power plants. Unless we get that electricity from a solar rooftop array that we may have at our homes, or from a wind farm, like the South Fork Wind Farm, with by the end of next year, we'll be feeding electricity right here into the East Hampton substation, and we'll be generating more than the entire East Hampton community uses during the entire year. So the town of East Hampton has set a very ambitious and very visionary goal of meeting 100% of our energy needs from renewable energy sources by the year 2030. This was before the state set a goal like that, and we'll be reaching that goal very soon. I've switched to heat pumps in my home. I'm a civil engineer by training. I had to build my own home, and of course that had to be a green home, or as green as it could be in the time. This is 30 years ago, roughly. And of course, initially I had a high efficiency gas boiler in there because we didn't have the technologies that we have today. But a couple of years ago, we switched our heating and air conditioning, of course, to air source heat pumps, and they're powered by solar arrays, and we're extremely happy with that. So you got to remember, heat pumps coupled with renewable energy is the power couple of technologies, right? We can now heat and cool our homes, our businesses with 100% renewable energy. We don't need to burn fossil fuels anymore. So that's the main reason I did it. I didn't want to wait for our boiler to conk out. It has a lot of benefits. Obviously, it's smart technology, so much more efficient. It has no, you're not running gas pipes or propane pipes through your home. You won't have any air emissions inside the home from your boiler, any carbon monoxide. It's the perfect technology. I compare it to a cell phone, right? When's the last time you've made a call from your old rotary phone, which, if anybody still has one, raise your hand, right? We're all using these things because it's just smarter, better technology, and that's the way it is here. I think I'll stop here because we're going to get into the nitty-gritty of it, but this makes a lot of sense. We got to do it. This bottle is going to be empty when I get out of here. And it is already empty when we look at how much the US can contribute to climate change. So we got to do this very quickly.
Thanks, Gordian. Any questions out there? I don't see any hands. How about
Biddle, would it be okay if I just added a little bit to that excellent description there about the grid and the cleanliness? Because I know this is an important issue. And it is true, as you just heard, that there still are fossil fuels in our generation systems now. But there's lots of very detailed studies that have been done on this all over the country. And I think it's important for the audience to understand that there's no reason for us to wait until the grid gets cleaner in order to do these actions that we're going to be talking about today. I think that's a common misunderstanding. Even today, if you part of the reason for that is because, like, imagine if you're putting in a new space heating system in your home today, it's going to last for 15 or maybe even 20 years. So when studies take that into account and you look forward over this next 15 years, and as you just heard, the grid's getting cleaner, et cetera. But because these devices are so incredibly energy efficient today, they use so much less energy than their fossil fuels counterparts. You combine those things of really efficient machinery plus a grid that's getting cleaner all the time, but going forward, the carbon savings from making these transitions, even today with the state of the grid the way it is, are really significant. Like in the Northeast, for example, the studies say it's about 65% reduction in carbon emissions. If you were to put that heat pump in tomorrow, because of all these things. So I just want to reinforce the point that yes, we're in this transition towards cleaner and cleaner energy, but it doesn't mean we need to wait in order to take these actions to electrify. The sooner we can do it, the better.
The energy calculation is what you're talking about. Sorry, go ahead, Jay.
So I think I'm a passionate environmentalist, but I run a business, and one of the things that I find is most important to people is that they want to know, it's one thing to have some costs and wanting to improve the environment, but most people fundamentally it's, hey, what's in this for me? Why should I do this that's going to help me today? I'm not going to fix the world's environmental problems on my own. So what's my small piece going to do here? And one of the phenomenal things, through working with homeowners as they go through this process, and typically, Long Island, when we're doing a retrofit, we start with this energy audit, and people start to become aware of the issues on their home and how much they're actually spending on heating their home, on cooling their home, on the fossil fuels that they have, through oil and gas, and you start to add up, and it's really sometimes, it's been a slow burn, something that they're just always used to spending, but they never really challenge the concept that, do you have to be spending this money? And you lived in an older house and you just assumed it had to be, it was drafty. It's an older house, so of course it's drafty. And Lena talked about, her home would, it was never quite comfortable because it would be, colder in the winter. Maybe one part of the house would be warm, another part would be colder. One of the great things about all of this is that, you can have a more comfortable home, save money in the process, have air conditioning that maybe you never had before. And even though, I hope people do it because, they care about the environment, but even if you don't care about the environment, there's something here for you. And there's some really great programs that are going to help to pay for these systems. And, Lena mentioned that one of the things that drove her to do it was she was worried about her air conditioning. It had stopped working. And, we get, there's a lot of people who buy a new boiler, fossil fuel system, or a new air conditioning, on the coldest day. They'll buy that system on the coldest day of the winter or the hottest day in the summer, and they're really forced into making that decision because they have nothing else, and now they're making a snap decision on something that, as Brian was saying, is going to be with you for the next 15 to 20 years and sometimes longer. And so you really want to kind of plan ahead a little bit, look at it, and then save the cost of of changing that system out, and you can get something that's much better. You can upgrade your home at the same time. And, I hope you're doing it for altruistic reasons, but if you're not, that's fine. There's other things in it for you. we can make your house more comfortable, save you some money, and get you in on some of the good programs that New York State has to offer.
So just to get into the nitty gritty, and maybe John, you can jump in here too. If you're building a new home, or you have an existing home, what is the let's start with building a new home. If you're building a new home, what are the systems that can be considered when you're building one out here to heat and cool the home efficiently with electricity? Let's say you have a pool, to heat your water, heat your pool water, cook. What are the systems that enable you to get to net zero?
Well, before we can get into the systems, I talk a lot about energy being a three-legged stool. And the first leg is you've got to conserve energy, which means you have a better building. As Lena pointed out, insulation was added. I'm sure they did some air sealing, stuff like that. So if you start out using less energy, that means that the equipment that you do put in could actually be smaller, can be more efficient. And then if you start talking about putting the third leg in, which is renewables, you can put less renewables on and accomplish the same amount. So it's kind of, like I said, a three-legged stool that you approach, that you look at all these things, which is easy when you have a new home, because we start with the building envelope, and then we start looking at the systems that will work in that building envelope, and then what do we need to do for renewables to make it close to net zero. The challenge becomes, as you point out, in an existing home, what can we do to make the building envelope perform better? Simple things like sealing around your windows, because you lose more energy through draftiness than you do through conduction through your walls. Caulk around your baseboards, because there's a lot of air leakage that happens along the floor level. Once you've done that, and maybe you look at upgrading windows, if you're changing siding on your house, you could insulate from the outside, which is very effective. So we start with the little things, and then the bigger things can be costing more. Then you start looking at the equipment, and there's air source heat pumps, there's geothermal heat pumps, there's the heat pumps for water heating that you can use. Some are internal, they take the inside air and move it back and forth. There are others that take the outside air and move it back and forth to generate the hot water or the heating for the hot water. Look at the appliances that you use, induction cooktops being primary instead of gas appliances. Look at your dryer. If you have a gas dryer, change to an electric dryer. All those things that can get rid of the fossil fuels that are being consumed in your house.
So if it's all out there and it's all available, what's the resistance? Like, this isn't happening at a pace to just jump off of where Gordian was talking. This isn't happening at a pace that's fast enough. So what is the resistance? What needs to be done to accelerate this transition to more efficient electric systems? Brian, maybe you've been in the sort of political hallways too, so maybe you could talk a little bit about where do you feel and where do you see the greatest resistance? What are the misconceptions perhaps in the marketplace, right, but also where is the resistance to make this transition?
Yeah, I think they come from a few places. I mean, I think I would start first with just information, and so today is a great starting point, because a lot of people, like my wife used to joke, if we could just get people to say the words heat pump, water heater, it's a victory, because most people don't even know what that is. So there's an information gap that I think that is the first hurdle, which people need to understand that these systems are available, they're cost effective, they're super high performance, they're not new technologies that are unproven. These technologies have been used in other countries for decades. They're relatively unfamiliar here in the United States, but most of these have been around for a really long time. Heat pumps have been around for hundreds of years. I mean, our refrigerators are heat pumps. And so the technology is very, very mature. So the first point is people need to be aware that these alternatives exist. I would say the second point of resistance is that the fossil fuels industry is very aware of the threat to their business model from these things. And so there can be, depending on where you live, a lot of misinformation about this that permeates, it's not just the fossil fuels companies, a lot of the contractors that you might run into, HVAC folks and stuff that are really used to this very conventional and reliable gas-based equipment. Oftentimes those folks are not necessarily excited about learning new tricks, so to speak, and moving away into these other new technologies. So you can hear misinformation from the so-called experts in the HVAC industry very commonly, that heat pumps won't work here, or you need a gas backup, or they're not as comfortable, all these things which are just patently not true. You often hear that from people who most people would trust, because these folks have been in the industry for a long time. And I don't say that to throw the HVAC contractors under the bus. These are really hardworking, good people, but oftentimes they're not embracing these changes that are so important. So that's the second one, the kind of misinformation. And then the third thing I would say has been an issue, and the IRA, which we'll talk about more, the Inflation Reduction Act, is a big help to get over that hurdle, is that oftentimes these solutions we're talking about, heat pumps for space heating, heat pumps for water heating, even induction stoves, oftentimes they're more expensive upfront than their fossil fuels counterparts. Now, when you, as Jay mentioned, when you throw in air conditioning into the mix and you're talking about a gas furnace with an air conditioner versus a heat pump, which will give you heating and cooling, that difference is less, but it can still be a premium to move to these high efficient electric devices. So the IRA, which we'll talk about later, I'm sure, which offers really good tax incentives, basically eliminates that premium that has been a part of the adoption problem with these high efficient electric devices, so that now the playing field is more even, so to speak, in terms of the choices from an upfront financial cost. But as Lana mentioned and Jay has mentioned, once you've installed these things, typically your operational costs will go down. But a lot of people are put off by the upfront costs, and so that's why these incentives that are available from the IRA are going to be so important. I think those are the three main ones: information, misinformation, and then cost, and all those things. Personally, I would end by just saying it's one of the reasons why it's so important that we have people in the community who have done these things themselves, who have experienced the benefits, who are talking to their friends and their family and their neighbors about them to help spread the word of mouth about how good these things are. And yeah.
I mean, I think that's a really important, just one second, Jay. I think that's a really important point, that if you're someone who is, getting to the end of your fossil fuel technology and you want to make this transition, or you want to make the transition because you want to make it for environmental reasons or any other reason, you're not alone. You can actually reach out to people in the business community who are have geared up like Jay, who can navigate the whole process for you, that can actually, get the rebates for you, install the technology, and be there for you to sort of integrate you into the new world. Before we get into the IRA, do you have a comment, Gordian?
Just a quick point, just to reinforce what Brian said. We are asked to make an investment to get the right forms of energy into our houses, into our homes and our businesses, right? We're not used to that, because it's up to now, we pay our energy bills monthly. We go to the gas station and buy gasoline, or we get electricity, and at the end of the month we pay our bills. We never had to make that investment. Now we have to, because these are decentralized systems. And so it is important that we, just like Saul said here in the video, that we have financing mechanisms and that we get rebates and other incentives. Just wanted to point out, on the energizeeh.org website, Energize East Hampton's website, if you want to look up what kinds of incentives are available, what kinds of rebates, go to the rebates and incentives menu and it'll be right there.
Super helpful, thanks. Jump in, Lena, yeah.
Yeah, I just wanted to add a couple of things. I had the opportunity not to put any of that additional capital into my investment myself. I could have taken a loan from the state and paid it down over the period of time that I, in fact, was getting the savings on my yearly bills. So I could have done this without having to take cash out of my savings account for this purpose. I chose to do it the way I did, but I think you can do it another way. The beauty of this is that over a period of years, you've paid off this investment because your savings are considerable, 40% about, I would say, in my situation. The other thing which we haven't really mentioned yet, but which I think is absolutely critical, we have a weird way of not addressing this, and I'm never quite clear on it, but the health benefits of living in a gas-free house are so huge, and somehow they never become the key point for us. And I'm perplexed about that. There is a UCLA study, for example, which says that children that are raised in a house with gas stoves have a 42% possibility of asthma that is greater than a child that is not raised in a house with a gas range. I mean, that's just a staggering number.
Lena, why don't we cue up that video? On the induction cooking.
Go for it,
Yeah.
because I have to make that
I was
transition.
actually going to have us see the heat pump video first, but since you brought up gas stoves, let's watch that one. Yeah, thanks.
The technology used by heat pumps is the most energy-efficient way to heat and cool your home. Now, that same energy-saving technology can be used to heat the water in your home. The water heater is the second largest consumer of energy in your home, so using the energy-efficient heat pump technology can add up to a lot of savings. Let's take a look at how this technology works. Standard electric water heaters use a resistive element to turn electricity directly into heat, which is transferred directly to the water. Gas water heaters use natural gas or propane to ignite a burner centered under the bottom of the tank to create heat. A heat pump water heater, on the other hand, draws in ambient heat from the surrounding air. Heat in the air is absorbed by refrigerant inside the evaporator coil, and cool, dehumidified air is exhausted. The refrigerant is then pumped through a compressor, which further increases the temperature. Heat is transferred throughout the tank by a water or refrigeration circulation process. This process of moving heat instead of generating heat makes the heat pump water heater 2 to 3 times more energy efficient than a standard water heater, saving you money and energy. Many heat pump water heaters are considered hybrid units that combine heat transfer and electric element technology to provide faster recovery time during high demand periods. In addition to heating your water, the heat pump water heater also cools and dehumidifies the air in the surrounding space as it transfers the heat to your water heater. So if you're in the market for a new water heater, remember that the cost to operate your water heater is just as important as the cost to buy the unit. Consider buying an energy-efficient heat pump water heater to save money and energy over the lifetime of your water heater. Smart energy, smart choices. Brought to you by Georgia Power.
I guess no wonder a power company is putting sorry to be such a cynic, but it's, that's how heat pumps work to heat water, but they also work to heat your home. I was gonna actually show the induction stove, the induction range and stove video too. We might as well do both technology videos right up, one next to the other, and then we can have a conversation about those technologies.
We're here at Troy's Farmers Market. I'm going to show you all how to cook with induction stove tops. 2 words you think about when you hear induction cooking. First thing that comes out in your mouth. Food. Hot food.
My only concern is that it accepts some of the metals and some it doesn't.
You can test your pans. You don't have to throw all your pans away. And you can test your pans by putting a magnet on the bottom of it. You have a cast iron pot, right? Sure. Right there. That is your induction cooking vessel. It's a ferrous, iron-based pans. Is basically what it is. I'm here at Troy Farmers Market. Crikey. When you hear induction cooking, what do you say?
Induction cooking.
Quickly now.
Oh, stove I wish I had.
So right now, I can take this up and this is always cold. This is the only thing. With induction cooking, only the vessel that you are cooking with is the vessel that gets hot. Everything else is cold. It's safer, cleaner, and healthier.
We swapped out our gas stove for induction 2 years ago. It's so much better because you can control the heat
extremely consistent.
a lot better. It's safer.
Yes.
And it's much easier to clean. I didn't think I would ever want to switch from gas because I grew up with terrible electric stoves, but these are like totally different and a lot better.
There's a new way of cooking. It's a healthier way of cooking using induction. If you want to know more information, go to nyserta.ny.gov. I said it right, yes.
So Brian, that didn't get into the health problems with having a gas stove in your house. Combusting gas, burning gas in your kitchen, and having gas in your house is a proven problem, for your health. I have one, and I wonder if that's why I have a raspy voice today. But maybe could you talk to us a little bit about that?
Yeah, Lena was mentioning the studies from UCLA, and there's others who have corroborated those studies. And essentially what we know is that burning fossil fuels creates all sorts of really bad byproducts: carbon monoxide, nitrous oxides, and fine particulates that are not generated when you're cooking with other techniques like electric or induction. So these things go into your house because there's this, if you live in a house with a really good ventilation system, much of that will be evaporated. But even with good ventilation systems, a lot of those things, particularly the nitrous oxides, don't get well ventilated and end up in your kitchen. In fact, in the time it takes to fry an egg, very likely that the air in your kitchen has higher levels of pollution that would be illegal if it was happening outdoors, because there's no regulations for indoor air quality. We have regulations for outdoor air quality, but essentially what's happening is you're polluting the inside of your space with gas combustion. And like Lena said, one of the major repercussions of that is asthma that you find, and children and elderly are most susceptible to this. I have friends who have asthma, and they tell me that they can tell when they walk into a house whether it's got a gas stove or not, just the way they feel when they walk into the house. And I believe them, because these things are triggers for asthma, people who have it already, but they are contributors to people who might get those illnesses over time. So essentially, if you think about it, imagine you were in a tent and you lit a propane stove inside your tent. I think intuitively you would know that would be a bad idea, or light a fire inside your tent with no ventilation, right? So the idea that we can burn things in our homes and some of that pollution isn't going to end up inside our homes is just not true. A lot of it does. The other thing that's been more recently reported, besides the combustion problems that I just mentioned, is that these devices, particularly stoves, gas stoves, leak methane into our homes, unburned methane, when they're not in use. And that's because of if you think about it, all those little fittings, anybody who's done any kind of plumbing, you know how hard it is to get things not to leak. Well, these gas devices have particularly stoves, have lots of little connections inside the device where you have opportunities for leakage. And it doesn't matter whether it's a new stove or an old stove. The Stanford study found that essentially every gas stove leaks methane into our homes. And so that's an issue, because unburned methane is bad from a climate standpoint. But the other thing that we're learning is that there are things like benzene, other dangerous chemicals that are in the natural gas that are constantly leaking into our homes. And these things, benzene, for example, there's no known permissible limit of benzene. So essentially, any exposure to benzene is extremely dangerous for health, cancer in particular. So I guess the point is that the more we learn about these devices that are in our homes that are leaking methane and producing these byproducts of combustion that don't get well ventilated to the outside, what we learn is that the indoor air pollution is a real problem in this country. It's particularly a problem for low-income families who have these these devices in their homes and who are very unlikely to have good ventilation systems. But anyone who has one of these in your home, I think you should consider it a health issue. And there's more and more people, like here in Multnomah County. The county just issued a report about 2 weeks ago, essentially saying the gas stoves are a public health hazard. So we haven't decided here yet. They haven't decided what they're going to do about that. But I think it's very likely that you're going to see potentially things like labels on stoves, much like we do with cigarettes, et cetera, just making people aware of the dangers of them. And you can't see it. You won't smell these things necessarily, but they're extremely bad for our health. And more information comes out about this all the time.
Interesting. Thanks, Gordian. Just 1 second. I just want to say to the online audience and the audience here that there's, of course, take Brian's word for it, but there's tons of material online if you just search online around this issue. I did for the purposes of this panel, and I'm really questioning having a gas range in my house. Gordian, sorry.
Just a quick additional point, Susan, to what Brian said. Out here, we use, we don't have a lot of natural gas pipeline infrastructure here, so most of us, I guess, use oil tanks or propane tanks to heat our homes. Can you do a show of hands here? Who's got a tank in the backyard somewhere, or a propane bottle and oil tanks? So what Brian just said is very important, but in addition, when we switch to heat pumps that run on electricity, whether that's produced by your solar panel or by LIPA, PSEG, there's no leaking oil tank in the basement, and there's no leaking propane tank out there. So propane and natural gas have a lot of leakage that contributes to climate change and makes this water level go down even further.
Any questions out there?
Yeah, so we've had a pretty stable number of 25 people watching our live stream on YouTube. So we're happy to have those people as well as our in-person audience. We encourage everyone to ask questions. We want this to be a platform where you're able to do that and get advice from these experts. So we do have one question on heat pumps. Can heat pumps power radiant heat?
Jay, I think, or John, either one of you guys are able to answer that question.
So there's a couple of different types of heat pumps, and John had mentioned, for instance, a geothermal heat pump, which is particularly good at generating warm and hot water. That radiant floor can work well with a geothermal heat pump. It's a little harder with the current versions of air source heat pumps to use radiant floors. We've done a handful where we've connected that that hybrid hot water heater, like we saw from Georgia Power, where we've done that for small areas of radiant floor, but it's really not designed to be a whole home solution. That's hitting maybe a kitchen and a couple of bathrooms or something like that. But today's air source heat pumps in particular are primarily designed around, for heating air and not the water that's in the radiant floor. But John, I don't know if you have more experience with that from a geothermal standpoint.
We have not done a radiant floor with a heat pump, but if you think about the video of the heat pump water heater, basically to get the radiant floor, you have to heat the water that'll flow through that grid in the floor. The heat pump water heater in itself can produce hot water up to about 150 degrees, which is well more than what you'd need to do. You want to have your radiant floor somewhere around 80 degrees probably by the time you have heat loss and everything else. So it's almost double the capacity. The problem is the recovery rate. With heat pumps, you're moving energy, you're not creating energy. And so the recovery rate is slower, and I think that's where they're not seeing quite the recovery that you need for an air source heat pump. They do geothermal systems, as Jay said, that will create radiant heat in the floor.
Great. So Gordian, I think I'd like to just take this discussion to grid capacity. I mean, if we had a major transition over the next 10 years here on the South Fork toward more electric, substantially more electric use, can our grid here handle that? And yeah, I mean, can you talk a little bit about that for us?
Yeah, well, the electric grid is a funny thing from an engineering perspective, because you have to plan the grid to meet the highest electric demand that may ever happen during 1 hour of one day during the whole year, right? Because nobody wants a brownout or a blackout. And so the system is sized, if we here in East Hampton use, let's just say 300 megawatts on the hottest day in August when it's super humid, our transmission lines, the substations and everything else has to be sized to be able to carry that amount of electricity to make sure the electricity keeps flowing. For us, in a way, we're in a lucky place when it comes to using heat pumps for heating, because that's going to happen in the winter and the shoulder seasons to some degree. So in the winter, we have no shortage of grid capacity because the system out here is a summer peaking system. So in some other places, of course, you will have to upgrade the capacity of the grid and substations, et cetera. But out here, that's right now not the problem. In fact, you could argue that this is going to be a benefit because we'll be using that asset more fully, and that should, at least theoretically, I'm not going to bet my house on it, but it should theoretically mean that over time, our electric rates would be less because the electric company will amortize the cost of building and maintaining that grid, that asset, over more kilowatt hours sold over more of the year. Right? So, but that's an esoteric point to make. The point is that what you're asking is, can the grid accommodate using heat pumps to heat in the winter and cool in the summer? And out here, the answer is yes.
I suppose you
can I add something to that?
Sure.
So, and one of the things to keep in mind is that today's heat pumps are very, very efficient air conditioning systems, so that in the case of East Hampton, where summer is the peak demand, if let's say 50% of East Hampton users replace their central air conditioning with high efficiency heat pumps, those heat pumps would be more efficient than the air conditioning systems that they replace. So we'd actually be, not to Gordian's point, utilizing the grid better in the wintertime, but we'd actually be reducing the peak demand in the summertime because these systems are much more efficient air conditioners than what they're replacing.
Yeah, I'd love to jump on that too, because it's a really important issue. The other thing, there was a study that was done here this is for the Northwest, but I would assume it's very similar around the country, is that there will be an increased demand in some places because of this transformation to all electric, but there are savings in other places. And Jay just mentioned one, which is more efficient air conditioning. Another one is that I don't know what it's like there so much in New York State, but here there's still quite a few homes that have electric resistance heating systems. And electric resistance water heaters, nationally, about 50% of the water heaters nationally are electric resistance. Replacing one electric resistance water heater with an electric heat pump water heater would enable you to replace 2 additional gas water heaters with heat pumps for essentially the same amount of electricity. So the point is that there are savings involved in this transition that we're talking about, where we're taking old, inefficient electrical systems and making them more efficient. You save a lot of electricity that some degree offsets the increased electricity that's needed to switch fossil fuels heating to electric heating. So, yes, we will need more, but it's much less than a lot of people think, intuitively, because of the savings that are available to us through these more efficient systems.
Gordy, I just want to double back in the conversation while it's on my mind. We mentioned the IRA, which goes into effect soon. Are those rebates, and is that that money, all that information about that money, that availability to consumers, is that on your site already at Energize EH, or are you going to update it in 2023 with that additional information?
Yeah, what is known as of last week, at least, is on the website and is built into the calculator that you find there. You can put your zip code in and your annual income, and it'll tell you what incentives are available. And in some cases, it's pretty significant amounts of money. But some of the regulations have not been finalized by the IRS, and the rules and regulations take some time, so it's still work in progress, and we'll keep updating it as we get that information.
So as Brian, this I think, actually I think I'm gonna go to John here just quickly. I don't want to ignore the possible downsides of all of this, and you've built a bunch of homes that are super efficient net zero homes. People move in and live there. What's the feedback?
The feedback is usually it's more comfortable, but it takes a little bit of getting used to a new system and kind of getting out of the mindset like I go home tonight and I've left in the morning and I've turned my thermostat down, and I go home and I turn it up and I'm instantly gratified with hot air blowing out of the registers. With, as I said earlier, the heat pumps transfer energy. So using setbacks is not always the best idea. And I think earlier we were talking about objections, and one of the objections I've had is I don't feel comfortable right away. And we ask them, well, what are you doing with your thermostat? Oh, we turn it down like we used to. Well, that doesn't work. And Lena, you said your home was more comfortable. It's letting it run. It's more efficient when it's running constantly than when it's up and down and up and down. What happens when it goes up and down is then you kick in the secondary, the backup, whether it's in the AC mode or whether it's in the heating mode, you kick in that resistance heat backup. And then that's what causes your electric bill to spike. We have a client that liked to open their windows in the summertime, but liked to sleep when it was 62 degrees at night, and they couldn't figure out why their electric bill was so high, because it wasn't working in the heat pump mode. It was working in the electric mode. So it takes some understanding of how to drive the car, so to speak. But once they learn that, I've had people say to me, you know, this system doesn't work. And I'd say, why? Because I don't hear it. You know, they don't hear the air blowing, because they have variable speed blower motors too. It all works on demand. So if you keep that consistency, you'll be much more comfortable.
John, Jay, Brian, where is the construction industry on all of this? Where is the demand? What's the market demand for this? And you know, where are we? The transition is multifaceted, right? It's going to have to come from consumers, but it also has to come from people who are interacting with consumers, whether it's vendors of appliances and technologies, or also just contractors, right? That's a huge topic, but I'd like you guys to sort of talk a little bit about that, because there's a lot of resistance there, I would assume, or at least, hey, this is the way we've always done it. We hear that across the board in everything that we do. So maybe you start, Brian, if you would.
Sure. So one of the things I track pretty religiously is sales data around furnaces, gas furnaces, and heat pumps and air conditioners. And it's been very exciting to see that in this last year, for the first time in history here in the United States, heat pumps are pretty significantly outselling gas furnaces for the first time. So that's a good thing, because now that means that we're putting in more of these and fewer gas furnaces. So that's good. But I'd say that, you know, it takes a lot more than that to get where we want to get to, because we're still selling a lot of gas furnaces. And part of I think the challenge that we have, that was in your question there, was that I think to a large degree, I would say the public perception of a premium house in this country, and the gas companies are very good at perpetuating this image of, you know, a house with a big gas fireplace in it and a big industrial looking gas stove. That's considered a premium home today by, I would say, the American public in general. So, and builders are very sensitive to that, because obviously if they're building homes and they want to be able to sell them and they think people want gas stoves and gas fireplaces, then they're going to build homes with gas stoves and gas fireplaces. So I think one of the challenges that we have is, and I love, you know, being able to see those pictures like John was showing of those amazing homes that he's building. They're obviously really aspirational homes. I mean, most of us would die to live in a home like that. And knowing that those are all electric homes establishes this different kind of image in people's minds about what an aspirational, premium, you know, really good living experience looks like. And so we need that. We really need those images in people's heads of like, oh, wow, that's something I'd love my house to be more like that. And so I feel that until that happens, we're a little bit of a disadvantage here, because builders will, you know, they don't want to take a lot of risks. Now it is changing. I see here in this area, there are quite a few builders who are all in on electric buildings, all electric buildings, and some of the larger manufactured home, like Ichijo, which is a Japanese builder here, and just recently put up about a 400 home development in the Portland area. They're committed to this idea of all electric homes, but I would say in general, it's still a little bit of an uphill battle on that front. You know, Jay and John, I'm sure you have experiences that you could chime in on this, but that's how we see it here.
Well, interestingly enough, John actually is, among many things, he created helped create a webinar that's a 1-hour online educational tool for builders to learn how to build all electric, if I'm not mistaken. I found that online someplace. Is that correct?
I was asked by the National Association of Home Builders to put together that seminar. I've also developed 4 certification courses for the National Association of Home Builders on green building. The basics, another one on building science, a third one on green building project management, and then one that's kind of involves more hands-on type project management based on climate zones. And to Brian's point, I developed these courses probably 10 years ago and have seen a huge increase in the popularity very rapidly. And just in the last probably 4 years, I've found that the course offerings and the demand for the courses has kind of started to taper off. And the Association of Home Builders, NAHB, has done research, and it's because codes have caught up. These practices that involve building better homes have become much more mainstream. So they are catching up. There are some production builders out in Brian's area, or in Denver, there's Thrive Home Builders. These are production builders. There's Meritage out on the West Coast. These guys are like way in front of what a lot of the building industry is, and they're actually pulling everybody else along. Fortunately, I'm in the custom building range, so that I'm dealing more with individual clients. But the production builders that have to meet these sales demands, they're starting to recognize that this is the way to go. There's the demand on the consumer's part for comfort. They don't always buy into energy efficiency, but they do buy into comfort, and they do buy into health. And builders have found that marketing those standpoints can be very successful.
When Berkeley, which was the first municipality to ban gas from new construction, this is, I don't know, 2018 or whenever they did it, the restaurants had a heart attack because the chefs did not want to give up their gas stoves, and they were completely allied to those stoves. Everybody's understanding at that time, and I think this continues right to now and becomes a chief piece of our resistance, is that when anybody thinks of an electric stove, they think of the one that their mother had, or I think of the one that my mother had, And I really hated that electric stove. And when gas stoves came along, I embraced them with nothing but passion. And no, I think just a huge number of people have not yet experienced induction. And that is exactly what happened with chefs. I mean, you can now go, you can Google, and you can find one YouTube or video after the other where chefs are talking about the joy that they're having with induction stoves, how they're putting it into their restaurants, into their homes. We haven't, I mean, that's why transition is so important. I mean, nothing happens overnight, and if something does happen overnight, it's a complicated equation. Things have to move slowly, and one person has to tell another, and one chef has to share it with another, and we have to see one more YouTube than we saw before, and this all is the way in which this occurs. You know, Brian was talking about learning more earlier, and I think if you learn more, you care more, and if you care more, you do more, and if you do more, you care more, and then you learn more, and then you care more, and then you do more. I mean, this is just circular. It's like the way the economy has to be. We have to put this into action, and I mean, this webinar is a perfect example of this. It's like, okay, so we don't have an overflowing audience, and we don't have a massive number of people online yet, but the truth is that one person leads to another person, which leads to another person, and that's the way this has got to go, because the fossil fuel industry is massive, and the disinformation campaigns are massive, and we are individual people, and I say power to the people.
Well, Lena, thanks for that. I think a lot of people will make the transition because of what you say. People will make the transition because their technologies are failing and they need to make a choice, and they're going to make the right choice or the choice to go electric. People are also obviously persuaded by Gordian's powerful, and we all agree, we all know what's happening with carbon in the atmosphere. But then, of course, there is Jay's point, and you know, I think a large chunk of the population needs to feel that they're going to get something out of it personally, quickly, intimately, and you know, that is part of why we're here, trying to persuade people that this is safer, cleaner, more efficient, and in many cases, cost efficient. Well, with that, let me just pause for a second, because we've got 4 minutes left, and we may have questions, and maybe members of the panel have things that we haven't covered they want to mention. So let me just go to questions.
Right, we do have some questions in the chat about geothermal heat pumps. So one of them is, what are the property lot size requirements to do a geothermal heat pump? And the other one is about depth to groundwater issues here in East Hampton with installing geothermal heat pumps.
So let's just, when we talk about lot sizes, I think they're talking about, you know, how much space do you need to do geothermal, not like what the zoning codes are. Jay or John, I think you guys would be best equipped to answer that question.
Well, there's
I am not familiar with the specifics for that.
Go ahead, John. Let's go with John.
You can have a horizontal field, which would take up a lot more landscape or land, or you can do vertical wells. There's also, within those vertical wells, there's two types. There's an open loop where you take water out, circulate it, and pump it back into another well, or there's a closed loop. I would not recommend open loop out here because the salinity of the water and water quality, and it'll degrade the mechanical system. But you can do a closed loop, and you may, depending on the size of BTU requirements, you may have 2 wells, you may have 3 wells, you may have 4 wells. So the vertical bores will fit in a tighter lot a lot better, but there's still code issues of separation to septic systems, to water lines, stuff like that. So it's more of a lot by lot type of situation.
Jay, do you want to add anything to that? What's your experience with geothermal and space out here to do it, and water table issues?
So we really don't get a lot into geothermal. We find it's much easier to place air source heat pumps than geo, and moves along much faster.
Any other questions?
Well, I'm just wondering if Brian wants to talk about the differences between geothermal and air source, because there are, I think.
Sure, jump in, Brian, if you
Yeah, I guess I'm not super familiar with geothermal because around here, it's just not a thing. I mean, the air source heat pumps have gotten so good now and they're so much cheaper to install that people just don't do geothermal here. It might be a little bit different in your area with the slightly, the colder temperatures, but here it's just not it. It's not worth it.
Got it, okay. Any other questions?
We have more of a comment in the
Sure.
chat. So someone said that they have interviewed 2 builders in South Dakota, an area not known for its moderate climate, and both of those builders now install geothermal heat pumps more than 50% of the time.
Gordy?
Just a quick reminder, maybe Jay, you can talk about the need for cold climate air source heat pumps. There's a bit of confusion sometimes about that with people.
That's a great point, Gordian. So heat pumps have been around on Long Island since the 80s, and the idea was pumping heat from the outside into your home. But the ones that have been around the longest really were designed for moderate climates, and so for a long time had a reputation that they didn't work here because it was too cold. Now there's a category of heat pump that's considered cold climate, and there's several different groups that do ratings on that. In the Northeast, it's primarily the Northeast Energy Partnership that does that, NEEP. And these are systems that are designed to run down to below zero and provide typically will provide full load down to 5 degrees, and most of them will keep running down to negative 15 or so. So they're really more than adequate on Long Island, where our design temperature is maybe 15 degrees, and they're used all around New York State and into New England, where it's much colder than here. And so if one of these is properly sized, they really they can really handle pretty much anything that Mother Nature is going to throw at it in terms of temperature.
Thanks, Jay. Yeah, Gordy.
Just to make a final point, all of these things, if you have questions on it after this, go to Energize East Hampton, energizeeh.org. We've designed this as a one-stop shopping, whether you want solar, you want an energy audit, you want a heat pump, you name it, you can find it there, and you can just click on a button and put in your name and contact info, and people like Jay will contact you.
Thank you, everyone. If you have questions for us, anyone on the panel, contact information and website links will be in the chat underneath on the YouTube channel. So if you go there later on, anytime from here on, you'll be able to contact and find the websites for the various people who are here and contact information. There are also some other links that we've posted in that chat, including how to calculate your own carbon footprint, and other relevant and interesting information that we're putting on there, right? So I'd just like to thank our panelists and thank our audiences, both online and here in the studio. That was a really interesting conversation, and we could have just kept going. I know there's just so much more that we needed to discuss, but I think we did a great job. Thank you very much.
Thanks for having us.
Thanks.